payload, right? Then remember that this word is not a suitable word for our syllabus, but they have added it. Basically, this word payload is used by Mr. Abdul Kalam. He used to talk about this one at that time when he was along with missiles, right? The word payload is a word which is basically used in case of missile technology. That is how much thrust is required so that the missile can push it up with so much speed. All those things are discussed under the heading of payload, right? Now, our discussion is not that one. We will not try to understand in terms of Abdul Kalam's language. We'll try to understand in our language so that we can get 4 marks. For that purpose, I can enjoy the game like this. Suppose, for example, there is a table, there is a surface, there is a floor, whatever it may be. And this particular floor, say for example, let us draw a straight line. Now, on this particular surface, suppose there is a ball here. There is a ball. When I am saying there is a ball here, if suppose ball was not there, someone is available here dancing. Who is that fellow? Air molecules are available here. When I kept this ball here, then what happens? This ball will displace the air available at this place before the process of keeping the ball. When you are going to sit on the chair of your classroom, before that one more fellow was dancing there on the chair. That fellow is called gas molecules, air molecules, mixture of gases. Once you just sat down on the chair, you have replaced all the gas molecules. Are you able to understand? Yes. There is a problem known as replacement of the gas molecules. Now, once you are saying, I have replaced the gas molecules, just take care of that one. Whenever you are replacing that, then what happens? Point number 1, body replaces air. ठीक है, चल बात समझ में आ रही है. Volume of body, volume of air displaced. अच्छा, ये बड़ा अच्छा रहेगा. This is better. ये word अच्छा है. Displaced is nice. चलिए, displaced. They are equal. Question is true or false. Remember that the body, volume of the body and volume of air are always dash equal. Volume of body, displaced air volume are equal. Okay, sir. When they are equal, can I create one question? Roll number 2 stood up and said, sir, I am having a question that mass of body and mass of air displaced are equal. Then what do you say? You will start shouting, no, 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 sir. It can never be equal. Why? Because density of body, matter of the body, density of the air displaced may be different. Even though it is a gas, body is also gas, for example, density may not be same. Therefore, remember that whenever we are talking about mass of body and mass of air displaced, they are never equal to each other. However, volume of body and volume of air displaced both are supposed to be equal. On that basis, I'll enjoy one more example. What is that? Acha, what is payload in this? With respect to this example, remember, difference of this mass is called payload. Difference of this mass is known as payload. Suppose, for example, if I have said mass of body is less, density is less, right? Lighter gas I have taken, mass of air is more, density is more. Then what happens? This body will go up. It will go up in the upward direction because it is having lower density. How to understand this example? Okay, enjoy your birthday. On the birthday party, your dad came along with large number of collapsible balloons, suppose, right? What is that looks like? This looks like to be something like this. In the pocket, polythene bag, You are having balloons like this, right? Collapsible. You can blow it up. You can compress it up. That type of balloon. Now, what you have done? Now, what he has done? Your dad has filled the gas helium, lighter gas, a gas which is having lower density as compared to that of air. If suppose it is so, then what happens? Once it is filled, the balloon will rise up. Okay, the balloon will rise up. Who is responsible for rising the balloon? Helium gas is raising the balloon. What is the meaning of that? Sir, helium gas, because it has lower density, air which has higher density, lower density gases will rise up. This is one side of the photograph. The other side of the photograph is no, 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 sir. Because density is less, helium is lifting itself. Helium is not only lifting itself, it is also lifting the matter of the balloon, right? The plastic with which, the rubber with which it has been prepared. And it is also lifting the thread or the rope which is attached to that one. So that gas which is having inside the balloon is having lower density. It has lifting capacity. It is lifting itself. And it also lifting dash matter of the balloon along with thread, right? If you have done work power energy, and when you do the problems of a person carrying load on the staircase, then what you will do? You will say, sir, mass of the body, he is carrying out his own body, and he is also carrying 50 kilograms of weight on his shoulders. Both of them we have to count. Exactly in a similar way, here in this case, helium gas or whatever the gas which we have take, but it should be having density less than that of air. That gas is lifting itself. Thus, that gas is lifting itself, and also it is lifting the matter. So, if suppose you take difference of the mass, right? In terms of this example, what happens after the story is over? This will look like, okay. Now, this is lifting. Because of lifting property of helium, it happens to be like this. Yes. What is payload? With respect to this example, remember, payload is equal to lifting capacity of gas. Very good. It is called lifting capacity of gas. We enjoyed this definition in our chapter known as gaseous state. It has its own meaning in missile technology, yes, but we have to discuss for this one. Lifting capacity of gas is measured in terms of payload. How do we measure that? Very simple, sir. Difference in mass. Difference in mass is always a positive quantity. Therefore, difference in mass must be taken as, what is payload? Payload is equal to mass. Which is heavier body here? Air. Mass of air displaced minus mass of what? Mass of gas. Which gas? It is there in the balloon. Mass of that gas, right? And what next? Wait a minute. Mass of gas? No, sir. Mass of material of balloon. Are you able to enjoy this point? Yes. You are climbing upstairs on the MS campus, first floor or second floor, along with a heavy bag on your shoulder. What you are doing? You are lifting your body. At the same time, you are also lifting the weight, additional weight. Exactly in a similar way, mass of the gas in the balloon plus mass of material. This is difference of this is known as what? Payload, right? Numerical problems once asked in IIT examination, but nowadays it is not expected because calculations are too much long. Therefore, we don't expect that type of calculations nowadays, right? Forget about it. However, theoretical discussion is possible. Come on. Now, mass of air displaced is equal to, I'll write here, is equal to mass of air displaced in this balloon. What is mass of air? Density is equal to mass by volume. Therefore, volume mass is equal to volume into density. Volume. What is volume? What is this R? Radius of this one. Because volume of body is equal to volume of air displaced, right? Both are same. Into dash. minus, I'll write here, I'll write here. My page is smaller. Just you adjust according to your way, writing systematic way so that you are able to understand properly, right? Okay, minus mass of gas. What is mass of gas? 4 by 3 pi r cube, right? Density of gas, and density of gas is less, remember, plus mass of material. Yes. Okay. This is known as payload. Come on, click on this, then we'll proceed for other applications. Come on, go ahead. Muhammad Zaid. Anybody by name Muhammad Zaid is available in the class? Okay, not available. Yes, sir. बेटा आप क्लास में आने का सलीका क्या है आपका? You have not written JL 41 40 रोल नंबर. कितने वक्त बोलना बेटा एक चीज को? डिसिप्लिन भी एक चीज है बेटा, डिसिप्लिन भी एक चीज है. प्लीज राइट डाउन योर सेक्शन 41 रोल नंबर लिखो, आराम से एंजॉय करो, लाइफ को एंजॉय करो बेटा. एंजॉयमेंट का मतलब है डिसिप्लिन, सिस्टमैटिकली एंजॉय करना लाइफ. देखो पूरे 64 में सिर्फ आप अकेले हैं, 64 पूरे लिखे हुए हैं सलीके से सबके पास. JL 40 JL 41 आपका डैश रोल नंबर डैश आपका नाम लिखिए, खूबसूरत दिखता. ठीक है, यही चीजें हैं जो आपको आगे काम में आएंगी. ये अल्फा बीटा गामा बेकार है. वेरी गुड, नो प्रॉब्लम, नो प्रॉब्लम. द क्लास इज ओपन फॉर ऑल ऑफ यू. गो अहेड, गो अहेड. गो अहेड बेटा, गो अहेड. अच्छा, फॉर दैट पर्पस आई हैव टू रिमूव यू. नो आई डोंट. आज तो खैर रह लीजिए, कल से याद रखिए. ठीक है, tomorrow notes you join in a systematic way. Now you continue the subject. Is it over? Shall I proceed? Is it over? Fine. Chaliye. Now, the one more way of enjoying application of gaseous ideal gas equation is something like this. What is that? Next example, G. Here also I am exclusively discussing about a problem. The problem will be given something like this. Suppose, for example, they say that there is a glass bulb, right? They'll mention something, say, for example, pressure is given to you as P1, right? I am saying this is bulb 1, and volume is given as V1, number of moles N1. This is something like this. Okay, nice. Then say there will be another bulb, right? Say, for example, bulb number 2, pressure in this P2, volume V2, number of moles N2, independently low. Here, suppose, for example, T is the same for both of them. Case 1, right? There are so many possibilities are there. Case 1. And what they say, they will say that these two bulbs are connected with a very narrow tube whose volume is negligible. So we don't consider the volume of this gas to be countable. Only we consider only two bulbs, right? There will be a wall here. He'll say something like this. And then he say, this is the situation available. If wall is open, what happens, right? The question is, what will be the pressure in the system, right? What is the problem? Sir, pressure I cannot change. Volume, number of moles I cannot change. But once I remove this, what we can say, wall, open the wall, then what happens? This is after this, it is called as a single vessel. And these problems are classified. Some lecturers give this a special name known as problem of connecting vessels. Connecting vessels का प्रॉब्लम बोलते हैं. कुछ लेक्चरर्स हैं नाउ साउथ में, अगर नॉर्थ में चले गए आप, तो दे यूज 3 to 4 क्लासेस टू डिस्कस ऑल दिस थिंग्स. कुछ भी नहीं है, एक क्लास में, आधी क्लास में खत्म हो जाता है टॉपिक. सिंपल है, उसको खींचना नहीं है, उसको समझना है. What is happening? Two things are happening here in this case. You have to learn two things. What is that? Once you remove the wall, then remember that if wall is removed, then what happens? Nothing will happen, sir. It will be a single vessel. Okay. What is the meaning of single vessel? Single vessel का मतलब ये है, pressure should be same throughout. Why? One vessel cannot have two pressures. We have learned it that equal forces exerted all the walls of the container. Yes, this implies pressure. Which pressure? New pressure, P dash. Neither P1 nor P2. P dash, right, is a constant. Single value throughout the vessel. ठीक है, ये भी एक हो गया. Next point और क्या हो सकता है? Sir, once you open this, then total number of moles n resultant is equal to dash. Job is over. N1 plus N2. N resultant is N1 plus N2. दर इतना ही समझना है. अब इसको जैसे जैसा प्रॉब्लम आता है वैसे उसको एंजॉय करेंगे. ठीक है, चलिए. इफ इट इज सो, कम ऑन. PV is equal to nRT. Therefore, N resultant, if you want to enjoy, how many vessels? Two vessels, N1 plus N2. N resultant. What is N resultant? N resultant is PV by RT. P resultant, V resultant by RT, that will be cancelled because he's saying same. This is P1 V1 plus this is P2 V2. In place of saying the word P resultant, let me enjoy this as what? P dash. Yes, sir. And this is V dash. What is V dash? Total volume. Acha. P dash, new pressure is equal to, go back to stoichiometry. M1 V1 plus M2 V2 by V1 plus V2. Yes, cheating. P1 V1 plus P2 V2 by total volume V1 plus V2. Yes, this is the normal simple way to enjoy the problem whenever we are having constancy of temperature. Suppose, for example, if temperature is constant, we can go ahead like this. No, sir, temperature is not constant. No problem. We'll create another case, another problem. Okay, come on, go ahead. Suppose, for example, now I'll try to create a problem, really a problem. What is that? Hmm. Equal volumes, two containers, pressure P is equal to 1 atmosphere, 1 atmosphere. Here we have hydrogen gas. What happened? There is something here. What is it? Something connection, negligible volume. We should not count the volume here. Suppose, for example, here I say total number of moles because it's open now. It's open now. Total number of moles. किसकी बात करेंगे? चलो हाइड्रोजन की बात करेंगे. ये प्रॉब्लम है. Today morning I think we have done another class. Okay, come on. Total number of moles कितने हो गए? 0.7. चलो ठीक है. Temperature 27 डिग्री सेंटीग्रेड, 27 डिग्री सेंटीग्रेड. ये कब की बात है? ये बात है 2:56. Right, 2:56 I'm having this one. Now he says the problem starts now. At 3 o'clock, I have kept it at 27 degrees centigrade. I make it as 127 degrees centigrade. Okay, then what happens? Sir, there is a problem. There is a problem. Yes, this problem will give you 4 marks. What happens? One of the system is at same temperature, other system is at higher temperature. Now it is a hot body, it is a cold body. What happens? He will ask you nothing, simply ask you find final pressure. As he said P dash, here also final pressure is equal to how much? Very simple, very simple. A beautiful enjoyment. At time T is equal to T1. At T1, PV is equal to nRT. ठीक है, चलिए प्रेशर कितना है? 1. ये भी 1, ये भी 1. पूरा 1 क्यों? ओपन कंटेनर है, इसका मतलब सिंगल वेसल. यहाँ नोजल था, यहाँ पे वॉल था, यहाँ पे वॉल नहीं है. इसका मतलब 0.7 मोल्स आर डांसिंग हियर एंड देयर, राइट. यहाँ से ये कमरे में से ये कमरे में, ये कमरे से कमरे में भाग रहे हैं. अब वॉल्यूम कितना है? नहीं मालूम है. क्वेश्चन नंबर 1, वॉल्यूम नहीं मालूम है. नंबर ऑफ मोल्स 0.7 आर 1/12. ठीक है. चलो ये जो कि क्लास की बात चल रही है, सलीके से पूरे का पूरा लेंगे. 0.0821, राइट. Temperature 27, case 1 27. No sir, we should write always in Kelvin scale. Therefore 27 plus 273, उतना सब आपको देने की जरूरत नहीं है. 300 डायरेक्ट, अलग अलग नहीं लिखा. Volume is equal to, just give me some time. What is the volume? I'll calculate. 0.7 into 0.0821 into 300 is equal to 17.24. चलो ठीक है, एक आंसर आ गया 17.24 लीटर्स. सर क्वेश्चन ये नहीं है. हाँ बिल्कुल नहीं, बिल्कुल नहीं. चलो ठीक है, क्लियर हो गया. अब एट T2 पे कहानी क्या होगी? T2 पे कहानी कुछ ऐसी होगी. यस यस, T2 की कहानी कुछ ऐसी होगी. सपोज फॉर एग्जांपल इफ यू आर सेइंग सर देयर इज समथिंग हियर, since it is hot and this is cold, therefore यहां से कुछ मॉलिक्यूल्स उधर शिफ्ट होंगे, ऐसा बताइए. सर कितने मॉलिक्यूल शिफ्ट होंगे? वेरी गुड सर, 0.3 0.35 minus x. बात समझ में आई? टोटल नंबर ऑफ मोल 0.7, इक्वल वॉल्यूम है, थोड़ा इधर थोड़ा इधर, इसका वॉल्यूम हम काउंट नहीं कर रहे, तो यहाँ पे मॉलिक्यूल्स काउंट नहीं करेंगे। सो टोटल 0.7, हाफ ऑफ 0.35, यहाँ से कुछ चले गए, 0.35 माइनस एक्स। यहाँ पे क्या हुआ, कुछ लोग आ गए, ठीक है, आने दीजिए, ये आ गए। अब आने के बाद once you have joining of these gas molecules, come on, let us enjoy the game. P dash, अब क्या हो गया, न्यू प्रेशर की बात कर रहे हैं आप, into V 1 लीटर, किसकी बात कर रहे हैं, किसी एक कंटेनर इज इक्वल टू, आ रही बात समझ में, V N, what is N, 0.35 plus X, वेरी गुड। R, ठीक है, रहने दीजिए इसको, छोड़िए बात, T 300, P dash into V hot body into R into 400. चले, right? You people are genius. Therefore, I'll enjoy the game in short, like this. Divide the equations. If you divide the equation, then what happens? Sir, nothing will happen. Sir, bekar hai aapke liye, because you people are genius, right? What is happening, sir? If you simplify all these things, this implies I got the value of x. Very good, very good. Yes. And once you have got the value of x, substitute the value of x here in this equation, right? Or if you are talking about this equation, go ahead, kahin pe daliye. This implies p dash into volume is equal to 0.35 plus x into R into 300, क्या हो गया, P dash का आंसर आ गया, like this. So he was asking actually what is final pressure, but by the way, I have enjoyed all the things that I have calculated. What is volume of vessel? I have calculated how many moles are shifting, and then I have calculated final pressure also. Like this, we have different type of applications. Take down that, then we'll proceed. Go up. सुहेल, न्यूमरेटर के वैल्यूज देखो बेटा, मैं क्या लिया, what I have taken in place of number of moles, देखो क्या लिया, what I have taken number of moles, you are asking. T2 volume is 1, how do you have written 1? Very good question. Can you please see that P dash into 1 is equal to 0.35 plus x. Can you tell me what is 0.35 plus x? It is number of moles in single vessel. हाँ, single vessel की बात कर रहे हैं, बात समझ में, are you able to understand? If you take volume as 1 liter, you should take content of that 1 liter only. Got it? No, no problem. Enjoy the life. Now you got it. Okay, okay, okay. Zahiruddin, just now I have explained that one only. That what boy Sohail is asking. Volume, sir, how you have taken volume in the second case? See that red color, what I have written, I have explained, but he said I didn't understood after explanation also. Then I have written that the circle for 1. If I take volume 1, I should take number of moles of that volume. I have taken 0.35 plus X. Then he said, yes, sir, now I got it. Now I think you also got it. Yes or no? जितना वॉल्यूम लेंगे उसके नंबर ऑफ मोल्स लेंगे. ठीक है. देखो टेम्परेचर को देखो और गौर से देखो. ये वॉल्यूम, इसका टेम्परेचर, और इसके साथ इसका वॉल्यूम, टेम्परेचर सब एक साथ ले रहा हूं. देखो ये टेम्परेचर, ये वॉल्यूम, मोल्स, ये हो गया केस वन. चलो फिर नीचे आओ. दिस इज वॉल्यूम ऑफ दिस कंटेनर, राइट साइड कंटेनर, करेस्पॉन्डिंग नंबर ऑफ मोल्स, करेस्पॉन्डिंग टेम्परेचर, ये सब देखो. इसलिए वन ले रहे. इसका मतलब आई एम अप्लाइंग. अच्छा, ये समझ में नहीं आया. तो यहाँ मैं लिखा था, देखिए इक्वेशन वन, इक्वेशन टू. एक कंटेनर के लिए वन इक्वेशन बनाया, दूसरे कंटेनर के लिए दो इक्वेशन, ऐसा. ठीक है. चलिए, आई होप योर डाउट्स आर क्लैरिफाइड प्रॉपर्ली. नाइस. Is it over? Okay, go ahead, go ahead, go ahead. Okay, okay, no, no, go on, no problem, no problem. Go ahead. I am not calculating that one. Nice, very good, very good. Is it over? Shall I proceed? Laik Ahmad, how can we know the moles in each vessel is half of the total number of moles? लाइक बेटा मैं जब थोड़ा आपको नहीं सबसे बात कर रहा हूँ मैं थोड़ा सी कड़वी बात करता हूँ राइट कड़वी बात करता हूँ उससे वास्ते थोड़े से बच्चे बोलते हैं सर ऐसा कैसा लाइक honestly speaking you are not studying at home anything because you have said in Avogadro's hypothesis under similar conditions of temperature and pressure equal volumes of all gases contains same number of molecules. Volume is same, pressure is same, temperature is same. Okay, okay. क्या करना आरिफ सर फोड़ लेना भाई पढ़ाना छोड़ देना सर फोड़ लेना PV is equal to nRT प्रेशर वॉल्यूम टेम्परेचर सब इक्वल रखा तो नंबर ऑफ मोल्स भी इक्वल होंगे ना बेटा यहाँ वॉल्यूम जितना है ये भी उतना है ये एटमॉस्फेयर 1 एटमॉस्फेयर ये 0.75 ये 27% पूरे 0.75 है यहाँ के केसेस सेम है यहाँ केसेस सेम है तो क्या होगा यहाँ 0.35 यहाँ 0.3 now this is the way with which we try to understand the gas laws and the ideal gas equation applications and all those things. This is known as part 2 of gaseous state according to my teaching, right? We'll go to problems based on that. Your Sunday syllabus will be gas laws and connected problems. What are the problems? Problems based upon up to case H. From the beginning, what we have said, all the gas laws plus ideal gas equation. Come on, let us enjoy the problems and please try to have a calculator with you and don't use calculator every time. Don't be slave of calculator. जब जरूरत है तब यूज कीजिए क्योंकि एग्जाम में आपको कैलकुलेटर नहीं रहेगा अब यहाँ पे एग्जाम नहीं हो रहा है एंड वी आर डूइंग लार्ज नंबर ऑफ प्रॉब्लम्स एग्जाम में मुश्किल से गैसियस स्टेट में एक आएगा या पूरे प्रॉब्लम्स में 25 क्वेश्चंस में 25 के 25 प्रॉब्लम्स नहीं होंगे और वो 25 में मेरे 10 होंगे फिजिकल केमिस्ट्री के 10 क्वेश्चन आते हैं यूजुअली 8 आना चाहिए 10 आते हैं वेन यू टॉक 10 के 10 प्रॉब्लम नहीं होंगे चलो ठीक है मैक्सिमम कितने होंगे 5 प्रॉब्लम्स होंगे तो वो आसानी से आप कर सकते हैं तो कैलकुलेटर के गुलाम मत बनिए कैलकुलेटर को साथ रखिए हमेशा जरूरत रहे बिल्कुल यूज कीजिए डोंट वेस्ट योर टाइम क्वेश्चन नंबर 1 a gas at 0 degree centigrade a gas at 0 degree centigrade and 1 atmosphere pressure and 1 atmosphere pressure occupies 2.25 liters 2.25 2.5 liters let us say 2.5 liters ठीक है मैं इसको चेंज कर रहा हूं देखो लिखने का तरीका चेंज कर रहा हूं ए गैस एट 0 डिग्री सेंटीग्रेड ओके रेडीमेड बना ले रहा हूं मैं इसको क्वेश्चन 1 एटमॉस्फेयर चलो ठीक है ऑक्युपाइज वॉल्यूम ऑफ 2.5 ऐसा लिखना सीखना हमको what change in temperature would be necessary अच्छा change is asking T1 P1 V1 what change in temperature right would be necessary if the pressure is to be adjusted to 1.5 atmospheres chalo pressure adjusted to 1.5 atmosphere and the gas has been transferred to 2 liters container okay that's all now when you are having this one very basic question simple question I am starting here sir we know that PV is equal to nRT in all the discussion you are taking the gas and transferring to other container what is the meaning of that number of moles remains the same you are taking the gas and you are transferring to another container complete transference R is of course a constant therefore equation is now become as P1 V1 by T1 is equal to dash P2 V2 by T2 खत्म हो गया problem what is P1 1 atmosphere what is volume 2.5 liters What is temperature? Temperature must be always in Kelvins, 273.15 is equal to P2. What is P2? 1.5 atmosphere. What is V2? 2 liters. What is T2? My job. This T2 will be in terms of Kelvins. But remember, answer must be in the language of question. The language of question is 0 degrees centigrade. The answer must be also in degree centigrade. So Kelvin, so 0 degree centigrade means what you should do? Minus 273. For calculations, please don't use this 0.15, right? 273 ले सकते हैं आप. चलो, go ahead. Go ahead. If it is possible to cancel, simply go ahead. Otherwise, use calculator. 1.5, 2.5 decimal cancel होगा. 5 is a 15, 5 is a 25, and it is 2.5. T2 is equal to 273 by 2.5, 2.5 to 5 by 2 लिख सकते हैं. ऐसा ऐसा टेक्निक्स निकालना, कैलकुलेटर को रखना बाजू, लेकिन इस्तेमाल कम करना, बहुत कम. ये प्रॉब्लम में जरूरत नहीं है. Three two seven six Kelvin. Sophia Nuddin, I said answer should be in the language of question. आंसर क्या में देना है? सेल्सियस स्केल में 54.6 डिग्री सेल्सियस. सोहेल, यस यू आर राइट. सुफियान, आपके पास डेसिमल का मिस्टेक है बेटा, चेक करो. केल्विन में बोले हम, वेरी गुड, बट डेसिमल का प्रॉब्लम है, राइट. एंड ट्राई टू रिपोर्ट इन टर्म्स ऑफ सेल्सियस. केल्विन में लाना, लेकिन सेल्सियस में चेंज करना. ठीक है. 54.6, yes, you are right. Answer is 54.6 degrees centigrade. Very good. Come on, question number 2. Shall I proceed? चलिए. Calculate volume occupied. Calculate volume occupied. We are starting with basic problems. By 7 grams of nitrogen. Very good. 7 grams, sir, grams. Grams का मतलब, yes, 7 grams. चलिए, ठीक है. Of nitrogen at 27 degree centigrade. 27 degree centigrade. Okay, मतलब 300 kelvins. Right. Answer is 54.6. You are right. And 750 millimeter of Hg. Pressure is equal to 750 millimeter of Hg. Chaliye. How to solve the question? Very simple, sir. First of all, let us go to basic information. PV is equal to nRT. But when I saw the information given to me, I am having weight. Therefore, PV is equal to weight by molecular weight into RT. What is pressure? 750 millimeter. Remember, you should not use millimeter because R is given in terms of liter atmosphere. So, क्या करेंगे? Whenever you are doing problems of gaseous state, it must be taken in atmosphere. Pressure must be in atmosphere. 750 by 760. Volume of vessel is my job. Weight of nitrogen 7 grams. Molecular weight of nitrogen 28. R 1 by 12.18, 1 by 12 into temperature 300. Therefore, answer is dash liters. Go ahead. Nitrogen, he said. Nitrogen. 7 grams. Okay, sorry. I'll write down here. It's better to write down. This is the case. 6.33 liters. 6.33 liters. Okay, okay. This fellow is saying 6.24 liters because we have taken this one by 12. Now there will be some problem. Yes, you are right. Go ahead. Nearest problem, we have to choose nearest option given to us, then we can go ahead. Shall I go to question number 3? Is it over? 6.33 students are saying. I got answer as 6.24 because in this book it is given like this. That means this fellow is using 0.0821. That will make difference. Okay, correct. Go ahead. Right. Therefore, I have given for that purpose only Abdullah Suhail. Therefore, I have given you that short number as what was that number I have given to you? 12.18 I have given to you. Are you able to understand? Yes. Go ahead. Otherwise, suppose for example, you are systematically doing very simple thing. Don't take 1 by 12. Take 0.0821. Okay, nice. Because I have completed 23 batches of IIT advanced with 1 by 12. But you people are saying, sir, what happens to integer? Then the answer is 0.0821. Short and sweet answer. Next, calculate weight of methane. This is your job. I'm not doing this one. Calculate weight of methane. Gas is methane, right? In 9-liter cylinder, volume is equal to 9 liters. At 16 atmosphere pressure, very good, 16 atmosphere. Okay. At 27 degrees centigrade. Chalo, to start this problem. Acha, he has given a hint here. ये भी एक तरीका है देखो. They say like this, take 0.08. ऐसा बोल रहा है उन्हें. In the problem he has given, take r is equal to 0.0. ये होता है एग्जाम में ऐसा. ये 1 by 12 है. चलो ठीक. Go ahead, go ahead. In integer also there will be no problem. In integers also there will be no such problem. Come on. Go systematically. .16 थोड़ा सा चेक करो बेटा थोड़ा सा चेक करो I think this is wrong answer is 96 yes you are right 96 you should have answered 96 those who are not getting that one please once again check your calculations. Something is wrong because no, there is no approximation. He's saying 0.08, take R value 0.08 only. Okay. Those who are saying 92.16, there will be some problem. Over. Right. Very good. That will stop here. Remaining problems will continue in the next class. Thank you. Assalamu alaikum.